Welcome to a new test and teardown video. We're doing some more DIY stuff. I really like this. This is super old tech. Back in the good old days when equipment wasn't really that frequency stable or frequency accurate, and you wanted to know what frequency you are on, you needed a reference coming from somewhere, right? So here in Denmark, we had a AM radio station that was transmitting on 245 kilohertz. And that AM radio station was very accurate. In fact, they locked that transmit frequency to something super accurate. And that was the reference frequency used in this area. So to use this frequency, of course, you need a receiver. And this is what this is doing. It's receiving this frequency and it is phase locking that frequency to internal oscillators. Here you can probably adjust the receiving frequency for peak amplitude or something like that. And then you can phase lock on. And then there will be a frequency locking oscillator something, and then you can select the output between all those different frequencies. There's even a divide by 2. So I can't wait to see if this thing works. This is definitely homebrew. Oh, and also I'm going to show you what is inside. But first, hey, how about we just power it up and see if it works. I can tell you this AM station is not operating anymore, so there is no radio station on this frequency. But what I can do is I can just come with a 245 kilohertz from something else. In here there will be a magnetic antenna, so it's a long ferrite rod with some windings, and so this aluminium here is a shield because the magnetic field will penetrate this perfectly fine, and it is really beautifully made. And then you turn this from maximum signal, so it's pointing towards the radio station. Of course, you could also just cheat and input the signal here, but then it needs to be like microvolts. I think it's more fun to just input the signal via some windings I put here, for example, and then we'll see if there's any light turning on or if there's any frequencies locking up or whatever is going to happen here. Yeah, let's try and play with this. Let's power up. Mains input. Okay, we got some okay. So if this is 10 megahertz, 100 kilohertz. Okay, let's have a look. Where are we? What exactly is going on here? Oops. Hang on a second. So now the scope is tuned for the 100 kilohertz output, and yes, it is very close to 100 kilohertz, so that is already quite impressive. See this little coil I made? Let's just stick it on the antenna. Let's just connect. Ah, damn it. So let's connect some signal here, right? Puff. So this is 245 kilohertz. Did something happen on the LEDs? Let's turn it off again. Yes, look at that. We got input. So hang on a second. So this is the output. I want to look at channel 1. Like that. So maybe I need to do something here, right? To see if this is in log or something. But it seems to be in log, right? Now I've been playing a little bit more with this, and there is a problem with the phase lock. Because if you look at the scope, you can see this is the 245 kilohertz, and this is the output from this unit. And you can see the output here is rolling. It should of course be locked together. I can see sometimes it's trying to lock a little bit and then it moves a little bit. See, if I hit the switch so it's not in lock anymore, and now I can adjust manually. Look what I'm doing here. Now I'm adjusting manually a little bit to that side and a little bit to that side. See? So it's quite clear that I'm very, very close here to a lock, and if I set it right there where it is as accurate as I possibly can, and then I hit the switch, then it starts to roll. And when it is now in this position and I try to dial the knob, I don't see any reaction. So there's probably a pot meter inside where you can adjust the locking range or how it is locking. That is not correct. So I think I need to repair this to see it's actually locking. But other than that, it is definitely alive. Something is going on here. And yeah, so that should be 10 megahertz output. Let's try and see if this is the case. Yeah, 10 megahertz output. And I could probably just dial. See? Now the knob is at maximum. And now the dial is at minimum. See? So there is a VCO somehow. And I'm able to dial in the frequency like that. Here we go. I can't wait to open this and see what is inside. And we are inside. The first thing I said when I opened the lid was, wow! I mean, look at that! It is absolutely beautiful! So this is the antenna input. And look what we got here. Fine tuning of the resonance of the antenna is done here. And all this is just the receiver. There's a test point going on here. So we got quite a lot of signals going in and out of the receiver. Ooh, what is that? Some sort of a... So this extra board we see here is something that was added later. See, we got... That was just power. We got input and output going on here. And then it's just getting into this signal and then it's connecting to another signal here. That is pretty cool. Other than that, yeah, what have we got here? That is a power supply. This is just probably just a 5-volt regulator or something, right? And the oscillator, the 10 megahertz oscillator, is of course voltage controlled. So yeah, here we go. This is the voltage control input. Because you can see here is the diode and the capacitor. And this is the circuit for voltage controlling Probably got the oscillator and a buffer and some more buffering, making it into TTL level. And then the output goes to God knows. I don't know, is this the PLL? Or is this? Yeah, okay. We need to divide quite a lot of times and doing a lot of stuff to be able to lock a 10 megahertz oscillator into a 245 kilohertz signal. And this is of course done in all this. So let's see if we can get a better picture of all the nifty stuff here. Here we go. 2-layer home etched PCB for all the divider stuff. And this is also where you select your output. So this board also contains all that kind of stuff. And this is the pot for the frequency variable. And that will be the switch to go in and out of lock. I mean, I'm not completely done playing with this. I want to power it up again while it's open and doing a little bit of scoping around here just to see what is going on. It could be fun if I could figure out why this thing is not locking correctly while the LED for lock is actually on. I mean, what do we do to fix this? $74.90, oh yeah. Lots of counters and some gates. Good old stuff. So this was definitely built quite a lot of years ago. And this is, as you can see, in the high end of homebrew, quality wise and build wise, design wise. Everything here is just really, really good. This is definitely not first timer. And wires there and tied up, and then we did some modifications, and then it wasn't so important to make it super nice. Maybe this was the initial idea of adding this PCB, as you can see here. Or maybe there was another PCB mounted here that was quite a lot smaller, right? And then, oh, we need something else in this. Then this is better. Oh yeah, now I remember. Now I know what it is. The frequency changed on the broadcast station. It was a few kilohertz. They moved the frequency back in the 90s something, right? And then all those receivers, they need to be modified with another divider, and then they could lock again. So that is exactly what this is. This is an additional extra divider thing. That is what is going on here. Oh yeah, that is funny. Of course I remember that. I just had a really, really cool experience here. Of course it was the frequency that changed, but he didn't update the beautiful text here on the front of the receiver. So what you need to input is not 245. Remember, the radio station changed its frequency to 243 kilohertz, and it was updated with this electronics, so of course it works and all that, but you need to use 243 kilohertz as the correct frequency. So what I did now is now not in lock. As you can see here, I can freely dial the frequency knob. Okay, so I can go a little bit too slow or a little bit too fast. So let's just put it here so it goes a little bit too fast. Now I hit the switch and bada bing, bada boom. We are of course in lock. So the thing works. Yay! It can lock and everything. Of course it works. Yeah, that is of course how it is. So 243 kilohertz. That is what it is. And then it works. Let me show you a little bit more close-ups. I don't know if this is a kit or is everything home design, home brew. I don't see any text on any of the boards. What I'm going to do now is look at all the date codes of all the ICs. Maybe I can figure out how old this is. I mean, the newest date code will probably be when this unit was designed, right? Now I've been looking a little bit on the date codes, and the original design seems like it's from 1975, or at least ICs that are actually that old, but the modification for frequency change is from 99, see? That is how it is, as far as I can guess. Of course, the ICs could have been on stock for many years before this was built. And also when you look at parts like this, a little bit off center, I think this is a home brew, home design, and it's actually quite beautiful.